In this video, we will be testing and recording the readings for an astable multivibrator. Now, you can see that we're looking at the connection points. The black wire is the negative, and it'll also be the negative for the testing point A, and I'm looking particularly at where we will put the leads for testing. That's the first circuit. This is the second part of the circuit, which is the output B. So without further ado, let's connect this. I've got the multimeter on the left. I've got my battery, and we can see the lights are on. They are actually just flashing faster. I've slowed it down a bit, and we can see they are flashing, the red light being a little brighter than the green. This is just basically the video not showing that it's actually flashing, or the visuals is a bit obscured, but they are flashing, and we will see by means of later an oscilloscope as well. So firstly, I will put my multimeter on, select the scale as well. So I've put it on volts, and then I will just make sure it's on DC and not AC. So I've got the DC sign on my multimeter because I've got a DC input. And so again, with reference to ground, we will use the black lead for the negative and the red lead for the positive reading. I'm getting 3.1, almost 3.2. This multimeter, it's actually not stabilizing the reading. In most cases, the reading will be stable, but you can just, if your multimeter does this, then this is worst case scenario, then you just take the highest value that you can see on the screen. Again, because the light is pulsing, the reading might move up and down depending on your multimeter. So again, there we found there about 3 volts almost on the dot, almost 1.1 volt less. So that's the multimeter readings. We will look later at recording this and putting it to paper, but for now, that is how you test the circuit with a multimeter. And so now we move on to the oscilloscope. And again, here it is good for you to have some knowledge about oscilloscopes. I'm using a digital oscilloscope. You also get the analog type, where you can get a reading. I will do a video at some point. Check the links, and then you can just see how the oscilloscopes match up or are done. So currently I am just connecting the leads, or the prongs and the leads of the oscilloscope onto the circuit A and circuit B. The circuits are represented by, as you can see on the oscilloscope itself, by a yellow and a purple band or leads. And so now I will put the oscilloscope is already on. I've just pressed auto just to get my signal through, and there we find a signal. So the green light is the purple signal, and the yellow light is the red signal, or it could be other way around. It doesn't really matter as long as you record the readings, or are able to read what the reading are from the screen. Now, this reading is not a reading that I'm particularly happy with, so I would probably want to change the range. And again, you should have some knowledge of oscilloscopes before you attempt working on an oscilloscope or taking a reading. And so there are just certain knobs that you can use to just zoom into the frequency or the wave. And so I'm just gonna make the wave smaller and make it more to be able to get an accurate reading. Well, the reading that I want, or that I've seen on the multimeter, I want to see it on the screen. For accuracy, actually, we should increase what the wave looks like, so that we can just find a more accurate reading. So what I've done there, you see a red light going on the right hand side, and you've seen just before this that the waves were actually moving, and that's in real time. The red button then, run stop, would actually freeze the screen so that we can look and count. What am I counting? You see those little lines on the screen? They actually are divided into segments, and so one line, 1 volt. But we will look at that again when we record it on paper, and this is next. So here we've got a data sheet, and we will, if you see those blocks, that represents the screen, and then we have, I'm not sure if you can see what's written on the page, is that the following measurements are needed. One is oscilloscope, one is multimeter, output 1 for both, output 2 for both. And it gives some notes there. Using an oscilloscope, measure the outputs with a reference to ground, and the same as for the multimeter. So this has got to do with the black lead and where you put the negative, otherwise your wave would be inverted. And so there's our first reading, 3 point something, and you can see it's circled on the circuit. I'm getting that reading from there, and I need to document this reading. So as we zoom into that, this is what we've done just now, and the bottom row using a multimeter. So you need to record output A, and so output A, and you can see there with a reference to ground pointing out again the black lead, which in the picture is in the right hand side, and the far left is the red lead. And so that reading we will record on paper, and it's just volts. You can put DC volts, but it's already, we know what it is. So as we zoom into measurement B, as you can see on the screen, again same, the testing lead with a reference to ground, again black lead at negative, or almost we can say in this case the emitter of that transistor, and we record the reading as seen on the multimeter. Alright, so that would wrap up the multimeter readings. So now the other one, the one that's a little bit more difficult, or not as easy as a multimeter, but we should have similar readings when we actually record. So let's see what the readings of the oscilloscope gives us. And so as we zoom into the first wave we saw, that's the first wave, the one on the far left, right on top, but we then further zoomed into it and we found that. I've just got another one that you can see there's 1, 2, 3, 4, 5, 6, 7 waves. I want to draw as little as possible but still get a reading, and so this is why I've even zoomed further into that on the oscilloscope, and I've gotten this picture there, and that's the bottom one. So I want to draw that one rather. So you can see what I'm doing now is I'm labeling the data sheet as to just line it up with the oscilloscope screen. So I'm on the top section there, and I've just labeled it. We'll put in an insert now as to show you what I'm doing. You can see this is what I'm doing, the little dots and the lines, white line in the center coming down perpendicularly. We need to draw that line in as well, almost as a reference point to count the blocks when we want to draw this wave. So there I've got my 2 naught points in, or 0 points, that I'm going to work from. And I think we need to still draw in the center line, just as center as possible. It's not really a big issue. If you can get it close to the middle, it'll just mean that you'll have a more accurate drawing. So right now, I'm also then on the center line putting in 1 volt, 2 volt, 3 volts, and just to put in a segment there. I'll put it in just now, just to show you where on the graph or on the screen I'm extracting this information from. So again, we need to know something about the oscilloscope. So here we go. You can see in the middle on the purple line, I am actually working on those segments, and you can see there, those are the lines that I'm using as 1 volt, 2 volt, 3 volt, the 5th volt, and 6, 7, 8, and so forth. So that is what I'm actually busy doing. Alright, so again, this wave, you can see I don't need all the way up till 20 volts. It's just for the sake of knowing where I am on the screen. And you can see the bottom segment, I've just spaced it a bit on the drawing, but it's fine as long as you get the wave in on the page. So right now I'm just looking at where the peak is of the purple wave. I can start top or bottom, doesn't matter. And so I will choose to start at the bottom. I've got almost 3 full blocks for the wave that I start at in the middle. Why do I start in the middle? Because it's a point I can start at. I can start literally anywhere, but I can count blocks from there onwards. All right. So you can see there those volts arrows showing that I'm getting my peak from counting those blocks. There we go. So I count again, almost 2.5 blocks. And so 4 blocks is 1 block that I'm referring to on my screen. All right, just to calibrate it a little bit more. And so again, there, if I look at 4 blocks, that is 1 complete block on the oscillator screen. All right, so that is the wave that we were busy with, the purple wave, or output B. I can write it in there if I want to. The drawings are in the way there, so you can't really see, but I'm just writing the output B for my references. Output A would be on top, and if I look at that, I would just be over 3 volts. I can just write 3. Again, for me to actually get a more accurate reading, I need to increase zoom in by making the wave higher, and then the blocks to make the volts actually zoom into the blocks as well, where maybe 2 blocks is 1 volt, or for argument's sake say 4 blocks are 1 volt, and then now you can get a more accurate reading to the comma. In this case, I am surmising it's 3 but not 4 yet, and it's almost on the line. So now I want to do the top one, the yellow wave, and again I start from the center line. You could literally start wherever you feel what makes you happy, so to say. For me, it's easy. I start from that point. I can easier count blocks to the left or right side. If I had started on the far right, I might miscalculate, because I don't really know how big the page is with regards to blocks. Again, it's an approximation. Your wave should just look approximately like the wave. So again, counting the 4 little squares on my drawing, making 1 block, and then I count them backwards or to the front, and I get my wave. Freehand is good enough. Just to make it darker, the pencil doesn't do justice to the actual wave, but it is good to do it in pencil. You don't want to make a mistake if it's an assessment, a test, or an assignment that's done in front of an invigilator or something. So this is my waves, and you can see there that it matches the oscilloscope. When the one light is off, the other one is on, you can see the wave on top that reaches. All right, and that would take care of the recording for wave A. And again, it is almost in the middle of 3 and 4 volts, and I just do an approximation, and if I look at the readings, it lines up.